So now let's see how to control device. Okay, what's the steps, what's the procedures you need to follow to program one device? Okay, so for each device, in general, you need to do three things. Okay, maybe may not be this flow, but you need to make sure these three parts are done correctly. Then your device can work. Okay, first one is hardware setup. So as you know that you have jumpers here. You have jumpers here. Okay? So basically why we have this jumper is, why we have these jumpers, one of the reasons is here, as I said, this base bar can work not only with your LPC, not only this type of LPC. It can also work with other type of LPC. Right? So for other type of LPC, you may have a different layout of your pins. Okay, so for example here, okay, so this is a socket to put your LPC, right? So not only this one can put here, some other type can also put it here. So the pins here for the other type of LPC may not be the same as this. So these jumpers give you the flexibility for the base bar to work with other LPC. Okay? And another reason is, for example, for this one, your LPC 1769 here, okay? You all know from the lecture and the tutorial already, some pins can have 4 different functions, right? You can give function 00, 01, 10, 11, right? And each pin here, when you do this connection, okay, since you see you have many devices on the base bar, so sometimes there is a case that one of the pins here has 2 possibilities. It can control, let's say, either this device or this device. So one of the LPC pins can connect either here or here. So the jumper here can make the connection. For example, if you put your jumper in this way, this pin is connected to this device. But if you put your jumper in the other way, this pin is actually connected to the other device. Okay, so this also gives you the flexibility to control this device, even for the same LPC. Okay, so now let's say you want to use this device. So you don't want this pin to connect to here, right? You want this pin to connect to here, so that when you program here, you tell this pin, okay, you should send 1 or 0. You are actually delivering the signal to this device instead of the other one, right? That's the reason you need to make sure that your jumpers are correct, so that the connections is there that you can control the device. Okay, so that's step 1. I call it hardware setup because you need to manually change the jumpers. Second is software setup. As I said, one of the pins here, okay, the pins here, they can have, each of them can have 4 possibilities maximum, right? Sometimes it can be GPIO, so you program it to function 00. Sometimes it's 01, sometimes 10, sometimes 11. So let's say your device here is running in GPIO mode. You need to make sure your pin here is also running in GPIO mode. Okay, so you need to configure this pin first before you can use, right? So this one I call software setup. Basically, you are doing pin cell configuration to the correct mode. Okay, and these 2 are basically the settings. So once you have done this, you are ready to program the bar, but you haven't programmed it yet. So the third step is write your own application program. Means how to detect this one. If let's say this push button is pressed, what other things are triggered based on this signal? Okay, that's your application program. So you need to make sure these 3 are all correct. Your bar will work correctly. Okay, any of these steps goes wrong, you won't have the correct output. Get it? So let me take an example, okay? Use an example to show you each step. For example, now my task is to turn on the music by SW4, which means if I press SW4, I play the music. Okay? If this is what you want to do, you see the first one, hardware setup, you need to know, confirm which device are you using. For this case, you are using SW4, right? And then this is the device on the base bar. That's why you need to go to these two documents to get the information about this device. Okay, so you go to base bar schematic and the base bar user guide. So this is the schematic I found from base bar schematic. Okay, let me show you the document. So this one, okay, this file is base bar schematic. You can see that it has multiple pages here, okay, but it's actually, okay, so from, oh sorry, okay, so at the beginning there are some overall description, but later on, okay, let's say from this page onwards, it actually draw device by device. And on this page, these devices are all GPIO devices. So they are drawn in the same page. So the next one, for example, is analog peripheral. So they try to classify those devices. Okay, so for this one, they are all I2C devices. Okay, so SW4 is a simple device which is running in GPIO mode. So you can actually find it from here. Or you can do Control F and search SW4. You will see this one. Okay, you will see this one. You will see SW4 push button. Okay, and look at this. Look at this. So here is your push button. Okay, so let me use my slides. So okay, so here is your push button. Okay, and at this side, okay, you have this pin. Okay, there's a one pin that connected to your SW4, and the name of this pin is PIO1_4 wake up. This is a base bar pin. Okay, so there is a pin on your base bar, big one. Okay, is actually taking all the data from SW4. Okay, taking all the signal from SW4. So you need to remember this one. Okay, 1_4. Okay, this is the information you need to get. And also you need to, okay, sometimes your schematic doesn't show the jumper. You see here, it doesn't show the jumper for you. So the schematic, the information from the schematic is not complete. So you better read another file, user manual. So it looks like this. This one. Okay, this one, if you look at the table of content, Chapter 4 is talking about each device. You see 7 segment, OLED display, UR, okay, and you have here, you see direct digital I/O, so this is GPIO device. You have SW4 here, SW3, SW5, all the others, okay? So you need to go to this section and read, okay? So I have screenshot that information. So this is the chapter for SW4. Okay, so read this. This document tells you the complete story of the device. So read this carefully to analyze which jumper, is there any jumper is linked to this device, and how should you set the jumper. Okay, so if you read, you see PIO1_4. Remember, this is a pin we just saw from the schematic, right? This pin can be driven from both SW4 and from BNC analog input via J28. Can you see that? So what's the meaning of this? This tells you that that particular pin, this pin, is actually connected to two different devices. One is SW4, one is BNC something something. Okay? So you can make a choice to link this one, to connect this one either to SW4 or BNC depending on your jumper. Okay? And then continue. Note that jumper 28 must not be inserted when SW4 is to be used. What does it mean? In order to connect this pin to your SW4, not BNC, you need to remove your jumper 28. Okay? So these are the information you should be able to retrieve from this document. Okay? And then where is J28? Usually the manual will show you part of the schematic, the board, and then tells you where this one is J28. Okay? So there are some big things that help you to locate this jumper. Okay? So what you need to do now is find where jumper 28 is, remove it, right? So this is your step 1. Okay? So I just show you this one. So here is your SW4. This is basically your jumper 28. So usually the jumper or jumpers for the device is quite close to the device. Don't try to look for it at like the other corner of your board. Okay? And then in order, because this moment you need to remove the jumper, instead in order to prevent losing your jumpers, you can put your jumper like this. Okay? So if by default, now your jumpers are all in default, right? By default, this jumper is actually here, is connecting these two pins. Now we just remove it, okay? Be careful, when you remove the jumper, don't try to remove this one, plug in somewhere else. Okay? Because you don't know what you have done. Okay, you may short some pins that's supposed not to be shorted. Okay? So remove means remove. Don't try to create another connection somewhere else. Okay? So remove, put it here. Or you can remove it if you have a safe place to keep it. So this finished step 1. Okay? Now basically if you want to sense your SW4, right? SW4, so whether someone is pressing it or not pressing it, you just know it by basically looking at this pin, right? Remember, this is the baseboard pin connected to your SW4. But remember, when we are writing our program, we are not programming our baseboard. Baseboard cannot be programmed. You are programming this small one. You are programming your LPC 176, right? So this is not the pin you can program directly. You must find out which pin on your microprocessor is actually connected to this baseboard pin when you plug the board onto the baseboard. Okay, so this requires you to look at the mapping between the small board and the big board. This is actually the page 2 of your baseboard schematic. Okay, so the second page of your baseboard schematic, you have this. So in the middle, these 2 columns, they are baseboard pins. Okay, they are baseboard pins. And if you want to find out what are the processor pin linked to particular baseboard pin, you need to look to the 2 sides. As I said, this baseboard can work with different processors, but for our case, we are working for LPC 1769. So you need to look at this column as well as this one. These two are for LPC 1768, which is very, very similar with ours. Okay? So, for example, this case, we need to find out which pin of our microprocessor is linked to baseboard pin 1_4, right? So look for 1_4 in the middle. Can you see it is here? Okay? It is here. So at the left hand side, so you go to the left hand side. You go to the left hand side. Okay? So there is a little bit misalignment here. But you can see it is here. Can you see that? Because this column here is 1_4, right? But this is not our processor. This one is our processor. Okay? So can you see that? This is the pin of our processor linking to PIO 1_4. So this is the one. So too big. Okay, so this one. Okay, you need to go all the way here. So this is the information you must know. So you found this pin. Okay, so when you write your program, we are programming this pin. Okay, we are programming this pin. Okay, now then, let's see how to program this one. So now basically, by this moment, you have moved from the device all the way from the device to the baseboard onto here already. Okay, you are moving from the device up to here already. So at this moment, you should look at the document for your LPC 1769. Okay, so this is a table familiar. You saw this in tutorial and lecture, right? So this is a pin configuration, pin function selection for all the pins. We are looking at P1.31. Okay, as I said, this one you see it can work as 4 different functions, depending on whether you set the function to 00 or 01 or 111 or 10, right? So for this case, the device we are using is SW4, which is a GPIO device. So you must set this pin to GPIO as well. Okay? So your target is to set this one to function 00. Okay? So then I think you already saw this in tutorial, right? How to set this one to GPIO mode is you write something like this. Right? So in the tutorial, this is a structure given. You can define your own name, and then you set the function number to 0 because 00, okay, on top 00011011, they are binary numbers. So here is decimal number. Okay? So we want it to be 0 function 00, which is decimal 0. Let's say if you want to be function 11, what should be the value here? 3. Okay? So this is a function number you want. This is a port number you want because you are talking about P1.31. Port 1, pin 31. Okay? And pin number 31. Okay? So by this, you set your structure correctly. Now you need to call this function called pin cell config pin. This is a function given by the library. You can call this, so this one will go and take the effect. The pin is set. Okay? If you just write this, nothing happens. Okay? Nothing happens on the hardware side. you call this function, it will set the pin. Okay? And lastly, you also, okay, so let me write it here. So this one is to set P1.31 to function number 0, 0. Okay? And next one, you also need to set the direction of this pin. So now my question is this pin should this pin be input or output? Should this one be input or output? If you are confusing about it, let's look at this. So you see, you are basically getting the signal from here to here, right? You can imagine you are here, or your processor is here, right? So what we have figured out is, this is your baseboard pin, this is your baseboard pin, and your LPC is actually here. And there is a pin called P1.31 is connected to here when you do this plugging, right? And how to know the button is pressed or not? You are sensing it, your LPC is sensing it, correct? So this pin, is it an input or output? Input, right? Because the signal is going this direction. Okay? So that's why here you are calling another function. Again, this is a function given by the library. You saw this in the tutorial. This is a port number. This is a bit value. Okay, you are looking at port 1, bit 31. Okay, and this one, if it's 0, is an input. If it's 1, is output. Okay, if it's 0, 0, input. 1, output. That's why here you are setting P1.31 as input. Get it? So this is some code you need to write to your program. But we're not writing it to the main function, because later I will show you, we actually give you a template, kind of template. Okay? So this one, init GPIO, is a local function. Okay? We try to let you add your code into here. Imagine later on when you are building your own system, you are not having only one GPIO device, you have multiple GPIO devices. You need to do this kind of pin configuration for all the devices. So try to group your code together. Okay? So basically under these local functions, you have all the GPIO pin configuration here. Okay? And later I will show you in the code, there are also other local functions, for example, init I2C, init SSP, that trying to group those type of devices, pin configuration under those local functions. Okay? So this is something you need to do. But for GPIO here, actually if you don't write this, it's still okay. Because, can you see that in the previous table? Can you see the preset value, or we call default value, is 0, 0. So for this pin, even you don't do any pin configuration, by default, the function is 0, 0. So even you don't write this one is still a GPIO pin. And by default, all your pins are input actually. So even you don't write this one, it still works. Okay? But just for this case, because all these are default values. Okay? But later on, let's say if you want this pin to work on other mode, you need to do that because they are not default value. Okay? So by default, all pins are input and in GPIO mode. That's why if you don't even write this, still work. Okay? But this is, in general, step 2 should be applied to all the devices. Okay? When you are not only working on GPIO devices. So any questions about this one? Then after this, you are ready to write your own code. Now whatever you have done is just settings. Okay, set everything correctly. Okay, so let me put it here first. So step 3 is writing your own program. Okay, for this case, this is our application program that we want to achieve, right? This is the way we want to use our SW4. When SW4 is pressed, we want to play the music, right? So how to do that? Firstly, you need to know, okay, let me go back to this schematic. Can you see here? Okay, you are basically sensing somewhere here, right? So you need to know what kind of signal is coming to you and what's the meaning of the input. For example, now, if let's say your button is not pressed, what will you get from here? 1, right? Can you see that? You have this pull-up circuit here. If the button here is not pressed, here is a capacitor, here is an open loop. Basically, there's no current flowing anywhere. Okay? And you will sense 1 here. When no press, you will sense 1. When it is pressed, can you see that there's a loop that you can, there's a current loop here, you can go in this way now. Right? So, if there's a current flowing like this, what will you sense from here? 0. Okay? So, when pressed, you will sense 0. So this is something you need to know before you can program. Okay? So whenever you see, now our LPC is keep monitoring this pin. If he see this one receiving 1, he knows nobody is pressing the button. When he see this one is receiving 0, he knows someone is pressing or holding the button. Okay? So this is the information you need to know before you write your program. Okay? So here, your application program is written in main function. Okay? And in your main function, basically you have this while 1, which is an infinite loop. Keep running here. Okay? So inside here, basically this one is to keep monitoring P1.31. You see, you need to keep monitoring it, not one time task, right? Not one time task. So this one is to keep monitoring P1.31. So whatever written inside while 1 is keep repeating. Okay? And whatever right before while 1 is running one time only. Right? So here I'm defining a variable later on to retrieve the data from here. Okay? And can you see that I'm calling my local function init GPIO. Remember our pin configuration, step 2, those code is written inside this local function. Right? You need to call it. If you don't call it, it doesn't take any effect. Okay? So you need to call it just once. Okay? Did the setup, that's all. Then you move on to your application program. Here, let's see how to keep monitoring this. So there is a function given by the library again called GPIO read value. Okay, I think you also see this in the tutorial. So whatever value here is a port number. Port number, right? Since we are looking at P1.31, we care about port 1. Okay, so if you call your function in this way and put 1 here, this thing, okay, up to here, this thing is returning you the entire port 1. The entire port 1. In port 1, you have a lot of pins. How many pins do you have? 32 pins. Okay? So basically, this guy is returning you a 32-bit binary number. Okay? So you are getting a 32-bit number. Okay, so 31 down to 0. You will get all of this 32-bit. But we only care one of the pins, right? One of the pins. So we only care about here, right? We only want to know what's the value here. Because this one, if it's 1, it's telling you that no one is pressed button. Remember, if 1 means no one pressed. If it's 0 means somebody is pressed, right? So you only care about this bit. Okay? How to retrieve this bit? What we did is we right shift 31 times. We right shift this whole thing 31 times. Okay? So your question mark will go to this location. Right? And the rest of the place we don't care. Okay? So this is what you got by this whole thing. Okay? Then again, we haven't retrieved this one out yet. So how to know this one is with bitwise AND. Okay, bitwise AND means you do AND for each bit. Okay, bitwise AND with another binary number, 0, 1. Okay. 0, 1 means basically you are AND with 0, 0, 0, 0, 0, 1. Right? 0, 1 is just 1. What do you get for this? What do you get for this? You do bitwise AND. You AND this one with this, AND this one with this, AND this one with this, and so on. You AND X with 0, what do you get? 0. Anything AND with 0, you will get 0. 1 AND with 0, you will get 0. 0 AND with 0, you will get 0. So all the rest of the place is 0 except the first one. What will you get here? Your question mark. Okay? Which means whatever bit you AND with 1, you will get back itself. If it's 1, you will get 1. If it's 0, you will get 0. So can you see the result here? You only have 2 possibilities. 1 or 0. Right? That's why for this BTN1, it only have 2 possibilities. 1 or 0. Depending on whether people are pressing the button or not. Okay? So now you are ready to use it for your if loop. If this thing equals to 0, if this whole thing equals to 0 means someone is pressing the button, right? So you are going to play song. So this is another local function. Okay, we don't talk about this at this stage. So here you play the song. Otherwise, you don't play basically, right? So you see this one is keep reading, keep running, keep running. So every time after you play the song, it will detect the button again. If it's pressed, it will be playing it will play the song. Otherwise, it will keep detecting this one. Can you see that? So this means, okay, by this moment, you complete this task. Okay? So this is a simple example. Okay, the device is simple. but I have gone through these 3 necessary steps that you must do correctly. Okay, so let's work on this. Okay, step 1, 2, 3, by modifying your demo.zip, the one you just run, the one you debug just now. Okay, add the necessary code inside it. Okay, so one more thing, let me show the demo.zip. So part 1. Okay, so this is main.c for demo. Okay, so what I'm asking you to, okay, don't care about the rest of the place. Okay, add the necessary code we discussed just now. Okay, so remember, okay, step 1 is for the jumper, you don't need to write any code. Step 2, you need to do the pin configuration. Can you see that? Okay, if you go down, you see this init SSP. Right? So these are the pin configuration for all the SPI devices. Okay? So you don't need to care about that yet. This is, you see, init I2C. And you have this init GPIO. You see now it's empty. Okay? You add the code here. Okay? But as I said, even though you don't write anything, it still work. If you, for this particular exercise, if you skip step 2, still work. So here, then you go into your main function. There is this btn1 equals to 1 given already. Why we want the default value 1? Because we assume at the beginning, no one is pressing the button. Okay? So, then you see this y1. Okay? So there are some code here. The accelerometer, just now the rotation 1, don't care about those. You have this, can you see that? But there's one line missing, right? You didn't add that btn1 should equal to 1, right? So let me try to write, let's say btn1, just now we discussed, is equals to GPIO read value. You read from port 1, you right shift 31 times, you end bitwise end with 0, 1, right? So you need to add this line as well. So as I said, this is a function given by the library. Pay attention of the capital or small letter. Okay? If you key in successfully, if you key in correctly, you will see that when you put your mouse here, it gives you some explanation here. If you type wrongly, you won't get this. Okay? Means your program cannot find the function. So let's say if you are curious what is exactly this function, you can put your mouse here, right click, open declaration. You see, you jump to the definition of this function. This is actually the LPC and the xxgpio.c. This is one of the files in the library. Can you see this side? This file. Okay? You see this file is actually from library MCU. Okay, there are so many files in the library, it's impossible to locate by yourself. So try to use the right click open declaration. Okay, and let's say if you are not sure how to use this, you go here. Can you see there's a brief explanation here telling you what's the purpose of this function. Is read the current state on port pin that have input direction of GPIO. Okay, so what is this? This one you see is port num. Okay, what is port num? Right here. Okay, parameter in port num, port number to read value in range from 0 to 4. Why 0 to 4? Because your LPC 1769, there are 5 ports. Okay, so you only have these possibilities. And your return, can you see that return value of GPIO port? You are returning the entire port. Can you see the type here as well? It's a 32-bit unsigned integer 32-bit number. Okay? And sometimes you even want to look at the code, what's happening here. Can you see the code here? You are actually getting FIOPNN. Remember this register? We discussed this in the tutorial. This is a status instruction, status register, telling you the status of this port. Okay? So you see it's actually returning the status of this entire port. Okay? So this is this one. So once you have done this, you add code here and set your jumper correctly, you should be able to play the music when button is pressed. Okay, can you try this?